To begin with today, I want you to pause the video and have a go at this probability matchup. So you've got 8 probabilities on cards on the right, and I want you to match the correct probability to the correct statement in the table. So you should have matched up your probabilities now, so here are the answers. So what we've been doing so far is looking at the probability of one event, so one thing happening, throwing a coin. What's the probability of getting ahead? Taking one counter from a bag. What we're going to do today is look at how we find the probability of two events or two things happening. Okay, and to do this we need to record all the possible outcomes of those two events in a systematic way, and we do that in a table called a sample space diagram. So if we have a look here, if we've got a 10p coin and a 50p coin and we flip them together, that's two events because I'm flipping two coins. Okay, and either coin can land on heads or tails. So if I want to know all the different possible outcomes, I can record that systematically in a table. So on my 10p coin here, I could get heads or tails. So my 10p coin, I'm going to use green. And then on my 50 pence coin here, I could get heads or tails. So my 50 pence coin is going to be purple. Okay, so I've got the top section of my table representing across the top the 10p coin and down the side representing the 50p coin. Okay, so the way I'm going to record what happens with both the coins is by reading in from the table. So if I read in from here and in from here, in this section of my table, it tells me, well, I could get a head on my 10p coin and a head on my 50p coin. That's one of my outcomes. This part of my table here, it's telling me if I read down, I could get a tail on my 10p coin and I could get a head on my 50p coin. Coming down to the bottom row of the table, reading down, I could get a head on my 10p coin. Reading across, I could get a tail on my 50p coin. And the last entry in my table, I could get a tail on both coins. So a tail on my 10p coin and a tail on my 50p coin. If we wanted to, we could just put some extra lines in that table so we can see it a little bit better. So I've got 4 possible outcomes. So I can have 2 heads and I can have 2 tails. Okay, but interestingly, with the head and the tails, rather than just having one outcome, I could get a head on one and a tails on other, I've got 2 because I could have it either way round. I could have a tails on my 10 and a head on my 50, or I could have a head on my 10 and a tails on my 50. So I have to consider the head and tails both ways round as 2 separate outcomes. Now I've got my table, I can use that to work out probabilities. Okay, so if we remember, the probability is the number of ways an event can happen over the total possible number of outcomes. So if, for example, I wanted the probability of throwing 2 heads, if I look at, well, what are the number of ways that event can happen? Well, in my table, there's my 2 heads. So the number of ways that can happen is, well, it's just one way. The total number of possible outcomes, well, there are 4 because I have got 4 entries in my table. So the probability of throwing 2 heads is 1/4. The probability of throwing a tail and a head, well, let's highlight that in a different colour. So if I use red to select the number of ways that event can happen, so throwing a tail and a head, well, I could get a tail and a head this way around, or a tail and a head this way around. So there are 2 possible ways of getting a tail and a head. So that probability is 2 out of 4, which simplifies to 1/2. Let's have a look at this scenario then. So what if I throw a dice and a coin together? What are the possible outcomes? So across the top here, I've got the outcomes that I could have on my dice. And down the side, I've got the outcomes I could have on my coin. And I can just fill in the table. So let's just give myself some rows and columns to make it a little bit easier to see what's happening there. Okay, so this square of my table, I could get a head on my coin and a 1 on my dice. Here, a head on my coin and a 2 on my dice, and so on. So this top row, because I'm reading across from the heads, it's all going to be heads. So a head and a 3, a head and a 4, a head and a 5, and I could get a head and a 6. The bottom row is the tails. I've got the tails here, so I could get a tails and a 1, tails 2, tails and 3, tails and 4, tails and 5, and tails and 6. So all the possible outcomes from throwing a dice and a coin. So let's use that to work out some probabilities. So probability of getting heads and 1. There we go. There's only one way of doing that. 1 in my table. So there's one possible way of getting a head and a 1 out of the total number of possible outcomes. Well, I can see that I have got 12 entries in my table, so it's 1 out of 12, 1/12. If I want to know the probability of getting a tails and an even number, well, let's use green to select those. So I could get a tails and a 2, a tails and a 4, or a tails and a 6. So there's 3 ways of getting a tails and an even number out of 12 possible outcomes. So that simplifies to a probability of 1/4. So once we've got our sample space diagram showing all the possible outcomes, we can identify from the tables the events that fit the probability we want and therefore work out the probability. Right, we're going to look at one more example, and I would like you to copy this one down into your book. So you can use the note sheet or you can copy it straight into your exercise book. Okay, so can we write down that a sample space is simply a way of writing down all the possible outcomes. So in this example, we are looking at spinning 2 spinners, okay, and we can see from the little pictures that the spinners have the numbers 1 to 4 on them. But what it's saying here is because we're spinning 2 spinners both with numbers on, that actually we're going to add the numbers together. Okay, the numbers are added together, which is why I've got a little add in the corner here. Okay, so draw the sample space diagram to show the possible scores. So in the first entry in my table, instead of writing 1, 1, it's saying add the scores together. So I'm going to take my 1 and my 1 and add them to make 2. Okay, next entry in my table, I've got 1 and 2, add them together is 3, 1 and 3 is 4, and 1 and 4 is 5. Okay, so we can quickly fill in the rest of the table. So the next row is the 2s, 2 add 1 is 3, 4, 5, 6, 3 add 1 is 4, 5, 6, 7, and you can usually, when you're doing a table like this, begin to see a pattern. 4 add 1 is 5, 6, 7, and 8. So those are my possible scores that I could get from adding the numbers on the spinner. And I can see that the number of entries in my table, 4 times 4 is 16. So I know that that's going to be on the bottom of my probability fractions on the denominator. So let's see about working out some probabilities here. So the probability that the score is 6. Okay, so it's often useful just to highlight. Oh, let's see if we can get that in a different colour. So there are my 6's in my table, a score of 6. So I can see that I've got 3 of them. Okay, so my probability is going to be 3 out of the total of 16. And I'm just going to get rid of that green. We have 16 so that we can use the table again for the next question. The probability that the score is more than 3, more than 3. So remember, more than 3 doesn't include 3, so I'm not counting the 3's. So more than 3, let's just identify them. So I can see that I've got 13 entries in my table of more than 3. So my probability is 13 out of 16. Lastly, what's the probability that a score is a factor of 16? So we need to remember our factors. Factors of 16 are the pairs of numbers that divide into 16. We can think of it as multiply to make 16. So our factors, let's use purple for this one. what you might like to do is just write down the factors of 16 in pairs. So remember, we did that systematically: 1 and 16, 2 and 8, and 4. Okay, well, there are no 1s in my table. There's a 2. Haven't got any 16s. I've got 1, 2, 3 4s, and I've got 1 8. So I've got 1, 2, 3, 4, 5 factors of 16. So my probability is 5 out of 16. So that's just a slightly different way of doing a sample space diagram by adding the number on the scores that we get. What I'd like you to do now, we're just going to have a quick reminder of factors and multiples, because we're going to need those in some of our questions. So remember, factors of 12, as we said, we can write in pairs of numbers that multiply to make 12, being systematic. So there will be our factors of 12. Multiples of 12 are the 12 times table. So that will be 12, 24, 36, 48, etc. Prime numbers, we might need to use prime numbers today, so let's have a reminder. 1 is not a prime number, so the first prime number is 2, and then we have 3, 5, 7, 9 is not a prime number, so we have 11, 13, 17, and 19. Those are our prime numbers to 20. Remember, prime numbers have exactly 2 factors, 1 and themselves. So now I'd like you to either do the sample space diagrams challenge sheet, or you can start on the super challenge. So open the sample space diagram super hypersheet and start on question 1. Okay, everybody start on the challenge or the super challenge.